It's like solving the system of equations by first one, rank of a matrix method. Second one, Gauss-Jordan method. Third one, Cramer's rule. Fourth, matrix inversion method. By using any of these methods, we can solve the given system of equations. Here solving nothing but here suppose the system of linear equations is consistent or not, or inconsistent. First of all, we have to find whether the given system is consistent or not, consistent or inconsistent. Consistent nothing but it having solution. The system has a solution, then the system is, we say that the system is consistent. The system having no solution, then we say that system is inconsistent. System is inconsistent. Now, first of all, rank of a matrix. Rank of a matrix. Rank of a matrix. Rank of a matrix, rank nothing but of the highest order non-singular matrix is called rank. The rank of a matrix is the order of highest order non-singular square matrix. The rank of a matrix is the order of the highest order non-singular square matrix. Okay. Now, by rank of a matrix. Rank of a matrix. Okay. First of all, we have to reduce the augmented matrix. Augmented matrix means here suppose system of non-homogeneous equations. Non-homogeneous equation means a1x plus b1y plus c1z equal to d1, a2x plus b2y plus c2z equal to d2, a3x plus b3y plus c3z equal to d3. This is called system of non-homogeneous equations. For homogeneous, here we have two types of equations: homogeneous, non-homogeneous. For non-homogeneous, here we have non-zeros. For homogeneous system of equation, we have zeros. Now, here we can write that system as matrix form as Ax equal to B. A nothing but coefficient matrix, A1, B1, C1, A2, B2, C2, A3, B3, C3, and X is called variable matrix. X, Y, Z, and B is called constant matrix, that is B1, B2, B. Here, augmented, it is called coefficient matrix. It is called coefficient matrix. It is called coefficient matrix. It is called constant matrix. Constant matrix. It is called variable matrix. Variable matrix. If you write AB side by side nothing but. If you write these two arrangements in only one matrix, only one arrangement, that is called augmented matrix, nothing but A1, B1, C1, D1, A2, B2, C2, D2, A3, B3, C3, D3. It is called augmented matrix. Augmented matrix. Okay? Augmented matrix. In this method, we are reducing the augmented matrix into echelon form. Into echelon form. Echelon form. E-C-H-E L-O-N F-O-N. Echelon form. Here echelon form means that is in the form of, here we have all elements in first row. Generally it starts with 1 0. Here we have some other numbers. Here we have 2 zeros. Generally means in any matrix, echelon form nothing but in any matrix, the number of zeros before the first, in a matrix, the number of zeros before the first non-zero element, before the first non-zero element in any row, does not exceed number of such type of zeros in the very next row, then that matrix is said to be, I'm repeating, in a matrix, if the number of zeros before the first non-zero element in any row does not exceed the number of such type of zeros in the very next row, then the matrix is said to be in echelon form. Means here, this is called first non-zero element. Before first non-zero element, we have 1 0. This is this very next row. It is first row, it is second row. Number of zeros here, number of zeros are less than number of zeros in next row. Suppose it having 2 zeros, it must have 3 zeros. This is called echelon form. Okay? Here generally we have like this. Means otherwise from top to bottom.
What if the zero starts from the first?
No, it is called echelon form. Ah, yes. Here we have non-zero element. In first row we have non-zero element. In second row, at least we require one zero. From top, otherwise, from top to bottom, zeros are increasing. Here, how many zeros are there? No zero. Zero zeros. 1 0, 2 0, like that. This is called echelon form. First of all, we have to reduce this augmented matrix into echelon form by using elementary row transformations. Elementary row transformations. By operating only rows, we have to reduce this form into echelon form. Okay, then by using some formula we can get the result. Okay, now it is called augmented matrix, it is called echelon form. Echelon form. For example, now look at generally. Now I am giving direct formula for this. Suppose the echelon form is of the form P1, P2, P3, P4, P5, P6, P7, P8, P9. Of course, it is just like Gauss-Jordan method also. Okay. Now, after reducing augmented matrix into this form, if pH not equal to 0, pH not equal to 0, then the system is consistent and having a trivial solution. A trivial solution. Trivial solution nothing but only one solution. Only one solution. System is consistent. Consistent means having solution. Inconsistent means no solution. Consistent, inconsistent also we have two type of solution. Only one or many means infinitely many. Now, if pH, here we have pH not equal to 0, then the system is consistent and having a trivial solution. Trivial means only one solution. Here, pH, suppose pH equal to 0, this is pH equal to 0, and P9 also equal to 0. pH equal to 0, P9 also equal to 0, both are equal to 0. Then we say that the system is consistent. The system is consistent and having infinitely many solutions. Infinitely many solutions. Infinitely many solutions. Infinitely many solutions. Okay. Suppose pH equal to 0, P9 not equal to 0, the system is inconsistent. The system is inconsistent. Means no solution. The system has no solution. Okay. First of all, you should convert you should reduce the augmented matrix into echelon form. Then simply by following these rules, we can get the answer. Okay. Now let us discuss this concept in our problems. Okay. Now take one problem on this. Now, not a problem. It is MSET question, 2013 MSET question. The system of equations, the system of equations 3x plus 2y plus z equal to 6, 3x plus 4y plus 3z equal to 14, and 6x plus 10y plus 8z equal to a has infinitely many solutions. Infinitely many solutions if a equal to dash. First option 8, second option 12, third option 24, fourth option 36. Okay. Now, try to remember echelon form. Again, look here. Here, the augmented matrix is 3, 2, 1, 6, 3, 4, 3, 14, 6, 10, 8, 8. This is called augmented matrix. We are reducing this form into echelon form. This is the symbol for equivalent. Means we are deriving another matrix from this. It represents that one only. These two are equivalent. Now, here you should remember one thing. Generally, for this, first make 1 0 here. Okay? In second row, first column, make 0. You can use either R1, it is called first row, second row, third. It is R1, R2, R3. We have to apply only row transformations. Okay? Now, to make 0 here, R2 minus R1, 3 minus 3, 0. Now, I am applying the operation R2 minus R1. Instead of R2, I am writing R2 minus R1. Okay? R2 minus R1. Now, the matrix is reduces to first row as it is. Okay? Second row having 3 minus 3, 0. R2 minus R1. 4 minus 2, 2. 3 minus 1, 2. 14 minus 6, 8. Okay? Then second. At the same time, better to make it 0 again, 0 by using R1. That is always better. Instead of R3, it is 6, it is 3. R3 minus 2R. Of course, you can utilize R2 also. To make 0 here, you can use R2 also. But I applied this concept. Okay? Now, R3 minus 2R1. R3 means 6 minus 2 times of R1. R1 is 3. That is 0. Here we have 6. Next, R3 10 minus 2 into R1. That is 6. Next, 8 minus 2R1. 2 R1 means 1. It is again 6. Okay? Next, A minus 2 times of 6. A minus 12. Okay? A minus 12. Now, again apply. Here we have 1 0. Here we require 2 zeros. Why? Because from top to bottom zeros are increasing order. If you have 1 0, here we require 2 zeros. But here remember one thing, while making 0 here, you should apply R2 only. Why? Because suppose if you use R1, 0 will change. That's why to make 0 here, you should use R2. Means R3 by applying R3 minus 6 minus 3R2. 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 Now that becomes here R1 as it is, R2 also as it is. Now apply this operation. Now 0, here we have 0. Here 6 minus 3 into 2, that is 0 here. Here also 0. Here A minus 12. A minus 12 minus R3. This is R3 minus 3R2. 3 into R2 means 8. What is it? 24. A minus 36. A minus 6. Okay? Any confusion? Now, look here. Now, observe the rules for this. Next rules means here P1, P2, P3. Now compare with the echelon form. P4 0, P5, P6, P7 0 0, P8, P9. Okay? P8, P9. Here what about P8? P8. P8 equal to 0. What about P9? For infinitely many solution, P8 equal to 0, P9 also equal to 0. for infinitely many solution, both must be 0. Therefore, a minus 36 also equal to 0. Therefore, a equal to 36. Okay? Are you understanding? Why? Because why we are equating this to 0, this to 0 like that is, again, after reducing into echelon form, for example, is it go? Are you understand this? Now I am explaining why these rules are applicable. Okay? I am explaining this point here. Any doubts? Okay. Now, look at generally the system of equations as a1x plus a2y plus a3z equal to d1, a2x plus a2y plus a3z equal to d2, a3x plus a3y, a3z equal to d3. Now, echelon form means augmented matrix becomes A1, A2, A3, D1, A2, sorry, A1, B1, C1, A2, B2, C2, A3, B3, C2. Okay? Now, the augmented matrix A1, B1, C1, D1, A2, B2, C2, D2, A3, B3, C3, D3. Just observe one thing. Actually, this can be written as AX equal to B form. AX equal to B form. What is A? A1, B1, C1, A2, B2, C2, A3, B3, C3. What is X? Variable matrix X, Y, Z. And what is B? D1, D2, D3. Now, it is 3 by 3 matrix. Matrix multiplication. It is 3 by 1, 3 rows, 1 column. By multiplying these two, the final matrix of the order 3 by 1. Then these two gets cancelled. 3 by 1 nothing, but it having 3 rows, 1 column. 3 rows, 1 column. Nothing but matrix multiplication, nothing but they are a1 into x plus b1 into y plus c1 into z equal to d1. a2 into x plus b2 into y plus c2 into z equal to d2. a3 into x plus b3 into y plus c3 into z equal to d3. Okay, we are converting the system of equation into this one. Again, reconvert the matrix form into equations form. After getting this form, okay. Again, convert into matrix form. How? Now, just listen to me. Suppose what is echelon form? Yeah, P1, P2, P3, P4, 0, P5, P6, P7, 0, 0, P8, P9. Again, convert into equation system of equations. P1x plus P2y plus P3z equal to P4. Second equation, P5x, P5 0 into x plus P5 into y, P6 into z equal to P7. Okay? 0 into x plus 0 into y plus ph into z equal to p. Okay? Now look here. Suppose P8 equal to 0, P9 not equal to 0, then what happens? P8 equal to 0. Suppose P8 equal to 0. Suppose. But P9 not equal to 0. It is some number other than 0. 0, 0, 0, 0 plus 0 plus 0. 0 equal to some non-zero number. Is it possible? 0 equal to, suppose it is 5. 0 equal to 5. Is it correct? Means for that type of equations, no solution. That's why here P8, P8 means this is pH. Suppose pH equal to 0, it is 0, it is non-zero. We are getting 0 equal to non-zero. That is meaningless statement. That's why the system has no solution. Okay? For example, second, suppose P8 equal to 0. P8 equal to 0, second condition. P9 also equal to 0. Then 0 equal to 0. Now here, but remember one thing, the system has three variables. We have to solve x, and x, y, and z. Which here we have three equations and three unknowns. To find three unknown values, we require three equations. Must and should. Okay? Otherwise, you won't get any unique solution. Why? Because, for example, 3x plus 2y plus 7z equal to 15. For example, look at 2x plus 5y plus 7z equal to 21. For example, but here we have only two equations. From these, by solving these two, we are getting, we won't get three values, three unknowns. Why? Because to get three unknowns, we require three equations first and should. For example, x plus y equal to 10. Here we will be having two variables. Find x and y. Find x and y. Not possible for unique value. Unique value nothing but here we have two unknowns. Get two unknowns, we require two equations at least. Okay? That's why suppose number of unknowns here, but equations are only one. Unique solution is not possible. Of course, by solving we have infinitely many. How? So y equal to minus x. By considering x as any real number k. X equal to some real number k. 10 minus k. What are the xy values? K comma k minus k. But what is k? It is not a fixed value. It may be 1, maybe 2, maybe 3. Any real number. This y value depending on k. So here k have infinitely many solutions, many values. Automatically y will get infinitely many solutions. Means here what you should have remember is, suppose number of unknowns 3, number of equations less, you will get a solution, but you will get infinitely many solutions. Why? Because the answer is in terms of k. K is not fixed value. K is any real number. Are you understanding? Therefore, suppose by converting the echelon form into system of equations again, if you are getting only two equations or only one solution, only one equation, you will have infinitely many solutions. Okay? Now, for example, therefore, suppose pH equal to 0, P9 also equal to 0, then the third equation will vanish. Now you are getting only two equations. Here, by solving these two, we are getting infinitely many solutions. Why? Because, for example, by trying to solve this, here P5y equal to P7 minus P6z. Consider z as some real number k. Now, what about y value? Y equal to P7 minus P6, Z means K by 5. It is Y value. Now by putting both Y and Z here, you will get X value. But X value, Y value, Z value depending on K. K is not a fixed value. That's why if K will change, automatically X, Y, Z also changes. That's why, or understand, for this type of equations has infinitely many solutions. Now, suppose first condition P8 not equal to 0. P8 not equal to 0. Suppose it is not equal to 0 means some value. Okay. P9 may be 0 or may not be 0. Then what you are getting? By again reconversion, by reconverting system matrix into system of equations, we have 0 into x, 0 into y, p8 into z equal to p9. Here p1, p2, p3, p4, p5, p6, p7, p8, p8, 9 are real numbers. Now what about z value? p9 by 8. It is one fixed value. What about second equation? 0 into x plus p5 into y plus p6 into z equal to p7. By putting z value here, you will get y value, single y value for y. Are you understanding? Now, again by putting y value and z value in the first equation is p1x plus p2y plus p3z equal to p4. By putting unique values for y value, z value, z equal to p9 by p8. By putting z value here, you will get unique value for y. By putting the y value, z value here, you will get single value for x. Means you are getting only one value for x, only one value for y, only one value for z. That means it having only one solution. Okay? Try to remember this. If simple, very simple, this is not 0, P8 not 0, then unique solution. Both are equal to 0, infinitely many solutions. Okay? P8 not equal to 0, then unique solution. P8, P9 both are 0, infinitely many solutions. But this is 0, this is non-zero. Inconsistent, no solution. By using this is, I think this is very easiest method to find the system of equations. Okay? Any doubts? Now, take another problem. Now, is it over? That's why try to remember. This is the one of the easiest. Why? Because It requires only two steps. First of all, make 0 here and here. In first step, make 0 in these two places. Then in next step, make 0 here. After getting into this one, within two steps, you are getting a echelon form. Okay? After getting echelon form, suppose pH, tell me again, pH not equal to 0, then system is consistent. System is consistent and has only one solution. Only one. That is also called trivial solution. Trivial solution. Suppose pH equal to 0, P9 also equal to 0. System is consistent but infinitely many solution. Infinitely many solution. Third, pH equal to 0, P9 not equal to 0, system is inconsistent. Okay? This is one of the easiest method and it requires very less steps also. Okay? Now go for another problem on the same concept. What on this problem? Solve the following system of equations. Solve the following system of equations by Gauss-Jordan method. Means same. This is also called Gauss-Jordan. Now here, given system of equations are x plus y plus z equal to 3, 2x plus 2y minus z equal to 3, x plus y minus z equal to 1. Find the following system of equations by Gauss-Jordan method. The given system of equations are x plus y plus z equal to 3, 2x plus 2y minus z equal to 3, x plus y minus z equal to 1. Okay, first write down augmented matrix, then convert into echelon form. Now, what is augmented matrix? Now here augmented matrix is 1, 1, 1, 3, 2, 2, minus 1, 3, 1, 1, minus 1, 1. Again, now first of all, your target is make 0 here by using R1 by applying R2 minus 2R1. Why? Because multiplying. Now it becomes here first row as it is, second row R2 minus 2R1, 2 minus 2 into 1, 0. Here also 0. Here R2 minus 2 R1 minus 3. Here R2 minus 2 R1 minus 3. Okay? Then here also make 0. You can. R3. Here R3 minus R1 gives 0. R3 minus R2. Now 1 minus 1 0, 1 minus 1 0, minus 1 minus 1 minus 2, 1 minus 3, 1 minus 3 minus 2. Okay, but here we have two zeros. Here zeros from top to bottom, zeros are in increasing order. Here we have two zeros, here we have three zeros. Means first of all make 0 here. That is final last. 1 1 1 3 0 0 minus 3 minus 3. Okay, here while making 0 here, use only R2. Don't use R. Why? Because these zeros also will change. Now make 0 here by using R2 only. That is, instead of R3, write down R3. Look here. To make 0, multiply this number with, means this row with that number, that row with this number. Automatically will get same number. Means R3 into minus 3 minus R2 into minus 2. Okay, multiply this row with minus 3, that row with this number. Now automatically here we have 0 0, here also 0, here also 0. Tell me which type of infinitely many solution. Why? Because pH, P9 both are equal to 0. Infinitely many solution. Here pH equal to 0, P9 also equal to 0. Therefore, this system of equations, this system has infinitely many solutions. Infinitely many solutions. Now, let us find those results also, those values also. How? Again, reconvert the echelon form into system of equations. Okay? Now tell me.
X plus y plus z is equal to.
Now we have 1 into x, okay, plus 1 into 1 plus 1 into z equal to 3. 0 into x plus 0 into y plus minus 3 into z equal to minus 3. Okay. Now last one, 0 equal to 0. From last equation we have got 0 into x plus 0 into y plus 0 into z equal to 0. Means 0 equal to 0 satisfied. Now z equal to 1. Z equal to minus 3y minus 3. That is z equal to 1. Okay? Z equal to 1. By putting z value here, x plus y plus 1 equal to 3. That is x plus y equal to 2. But number of unknowns 3. But number of equations only 2. That's why here y equal to 2 minus x. Now consider x as k. X as k. Y equal to 2 minus k. Okay? Z equal to 1, but z has only 1%. What is k? K belongs to any real number. Okay? K belongs to any real number. Any confusion? Now, take one more problem on this. Is it over? Now, the system of equations, the system of equations 2x plus 6y plus 11 equal to 0, 6y minus 18z plus 1 equal to 0, 6x plus 20y minus 6z plus 3 equal to 0. First option is consistent. Is consistent. Second option has unique solution. Is inconsistent. Is inconsistent. Fourth one cannot be. Now try. Here, augmented matrix is 2, 6, 0. Z is not there. 11. X is also not there. 0, 6, minus 18. But here generally we are writing equal to d1. Equal to d1 means here we are getting. Here also we have minus 1. 6, 20, minus 6 equal to minus 2. Why? Because it can be written as 6x or 2x plus 6y plus 0 into z equal to minus 11. 0 into x plus 6 into y minus 18 into z equal to minus 1. 6x plus 21 minus 6z equal to minus 3. Now already we have 0 here. Okay. Now make 0 here one by using either R1 or R2. Okay. Now apply R3 minus 3 into 2 means 6, then 0. 3 R1. R3 minus 3 R1. That is 2, 6, 0 minus 11. 0, 6 minus 18 minus 1. 0. 20 minus R3 minus 3 into R1. Inconsistent. Okay, let us. Now, what is it? 2. What is number here? What is the number here? Minus 6 minus 3 into 0, that is minus 6. Here, minus 3 minus 3 into minus 11. minus 3 minus 3 plus 33 30, it is 30. Okay, now again make 0 here. Now 2 6 0 minus 11. While making 0 here, use R2 only. Therefore, instead of R3, 3 R3 minus R2. Okay. Now, second row as it is 0 0. It is also 0. Yes, 0. Here 91. 3 into 30 minus 1. 91. Okay. Now it is in echelon form. Now pH 0, P9 not equal to 0, P8 equal to 0, P9 not equal to 0. Therefore, the system is inconsistent. No solution. Okay? Read out. Now, another method. Just one more example. Suppose by using rank, how to solve the system of equation by rank. Rank nothing but what is it? Yes, rank of the highest order non-singular matrix. Okay, suppose here A1, B1, C1, D1, A2, B2, C2, D2, A3, B3, C3, D3. This is called augmented matrix. Okay, this is called augmented matrix. A, that is A1, B1. This is called coefficient matrix. A is called coefficient matrix. This is called augmented matrix. Here, suppose rank of A means rank of coefficient matrix equal to rank of augmented matrix. Here, how many unknowns are there? X, unknown numbers, X, Y, Z. Variables, X, Y, Z are called unknowns. How many unknowns are there? That is also equal to number of unknowns 3. A1x plus B1y plus C1z. Number of unknowns. Number of unknowns. Unknowns means X, Y, Z. 3 value. It is always fixed for this type of problem. Suppose rank of A equal to rank of augmented matrix equal to number of unknowns, then unique solution. Then unique solution. I will explain what is how to find rank. What is meant by rank? Now second one is rank of coefficient matrix equal to rank of augmented matrix. That is not equal, that is less than here number of unknowns always 3. Less than number of unknowns, then system has infinitely many solutions. Infinitely many solutions. Okay? Of course, in echelon form, from echelon form only we can get this results. Suppose here in these two cases rank of A equal to rank of AD. Rank of A not equal to rank of AD. Then no solution. Okay, by using a rank method. For example,
So you don't need echelon form.
echelon.
You just need the answer on A form.
AD means augmented
But
matrix.
you need only that one. But you don't need
So
echelon
first of all, we have to convert augmented matrix into echelon form.
Then you will get none.
Echelon, we are getting a rank from echelon form only. Suppose, look here. Here, what is meant by rank? In this case, in echelon form, rank means in echelon form, rank equal to number of non-zero rows. Number of non-zero rows equal to its rank. For example, 2, 3, 4, 5, 5, 6, 7, echelon form 8. This is called echelon form. Okay. Now this is called A coefficient matrix. This is called augmented matrix. Number of non-zero rows nothing but if all the elements are zero, that is called zero. If all elements having zeros, that is called zero row. If you consider only this, of course, it is 589. It is called coefficient matrix. It is zero, but it is not zero. That's why we consider this as non-zero. If all are zero, then that is called zero. All are not zeros, then that is called non-zero. Here, how many non-zero rows are there? 3.
So it is having a unique solution.
It is 5, 8, 9. This is called augmented matrix. How many non-zeros are there? Here also 3. Rank of A 3. Rank of A nothing but number of non-zero rows in A. Number of non-zero rows in coefficient matrix. Rank of A number of non-zero rows in augmented matrix. Number of unknowns here X, Y, Z number of unknowns. Here rank of A 3. Rank of AD also 3. Number of unknowns also 3. No doubt at all, you will get unique solution. Suppose already we done one problem. If all are zeros, then infinitely many solutions. Infinitely yes. Now here, what about rank of coefficient matrix? 2. It is called zero row. It is called zero row. Non-zero rows only 2. Rank of A is 2. What about augmented matrix rank? That is also number of non-zero rows only 2. 2, 2.
Yes, sir.
That number of almost 3, less than 3. Therefore, infinitely many solutions. Are understanding? Suppose it is 9.
There is no solution.
What about rank of coefficient matrix? 2. Why? Because this is called coefficient matrix. It is zero, non-zero rows only 2. It is 2. What about augmented matrix rank? Number of non-zero is non-zero. Why? Because mine is there. Rank is 3. Here rank of A is not equal to rank of A2. Therefore, no solution. Any doubt? Okay, let us discuss some problems tomorrow. Thank you.
You're all there.
Follow us.
Where is it?
Stop broadcast.
That now it is 11.
ना दोस्तों से बात करो
Where is it? I can't see the faces.
फेसेस नहीं है तुम बात करो दोस्तों से
Are you hi people? Go.
Okay.
Oh, yes, sir.